Hi, welcome to my video on tips when solving polynomial equation. What I'm going to go through in this video is a series of tips that I use to zero in on the roots of a polynomial equation. Now, number one is write the polynomial in descending order and fill in the missing terms. So here we have an x squared 6x cubed minus 4x equals 0. So descending order would be x cubed plus x squared minus 4x plus 6 equals 0. 3, 2, 1 constant, and this constant is x to the 0. That 6 is understood to be 6x to the 0, and x to the 0 is a 1, so that's why the constant term has no x with it normally. Descending order here would be I have a 7x squared x4 x cubed, so we start with x to the 4th, then we go with x cubed, and then we go with an x squared, and we have no x, so I put a 0x and a plus 7. And again, the constant term is on the end. 4, 3, 2, x to the 1, 0 times x to the 1 is 0, so I just put the x in a descending order. This is especially true to do this if I'm going to do synthetic division. Number 2, the degree of a polynomial is the number of roots. This is x squared x constant, so the degree is 2. So the number of roots, so there are 2 roots. May they be real or imaginaries. This is x cubed x squared x. The degree is 3, the highest exponent. So we have 3 roots when we solve this equation. This is x to the 4th. So the highest degree is 4. So we have 4 roots. So the highest degree, which is normally, if it's in descending order, is the degree of the first term in descending order. That's the number of roots. Also, I look for if x is a GCF, factor the polynomial. And if x is a GCF, 0 will be a root. Example, notice that x squared minus 2x, x is a GCF, so I take it out. So I have x minus 2 equals 0. So x times x minus 2. And because 0 is a factor, then because x is a factor, 0 is going to be a root. So if you put 0 in this expression, you get a 0. If you put 0 in this expression, you get a 0. And 0 minus 0 is 0. And here we have 3 is a common, and we have an x squared. So we take out the 3x squared, we get an x minus 4. And again, we have x as a factor, so therefore we put 0, x squared equals 0, x is equal to 0. So 0 is a root, but there's 2 of them. And in this expression, we have we have x4, x cubed, x squared, x. So we look way over here, so I see a 4 is a factor of each term, so 4x is a factor of all these terms. So 4x to the 4th divided by 4x is x cubed. Negative 8x cubed is a negative 2x squared. 12x squared divided by 4x is a plus 3x. And negative 4x divided by 4x is negative 1. Again, x is a factor outside, so that means 0 is a root. So anytime you have expressions with all x's in it, guaranteed to have 0 to be a root. So I always check for that, and I take it out before I begin to solve further. The other thing I look for is if I have 4 terms, I try grouping. So if you have 4 terms, I group them in pairs, 2 and 2. So in these 2, I have an x squared. So I take it out, so I get an x plus 1. And here I see that's a plus, whatever this sign is, that's what goes here. 4 is common, so I take the 4 out. 4x divided by 4 is x. 4 divided by 4 is 1. And notice we have x plus 1 is common, so we have x squared plus 4 left. So we keep on solving this, and we make x plus 1 equal to 0. We have x squared plus 4x equals 0. and we keep solving it, and we have already practiced that. So here x is equal to -1. Here x squared equals -4. Square root of x squared is plus minus the square root of a -4. So x is equal to plus or minus 2i. Square root of 4 is 2. Square root of negative numbers is an I. And right here we have 4 terms, and can we group them? So we just check. I see x squared is x cubed is common here, because in a 5 and a 3 the smallest power is common. So x to the 5 divided by x cubed is x squared. X cubed divided by x cubed is a -1. I see a negative, so whatever this sign is here, that's what goes there. And I see an 8, so I take a -8 out. -8x squared divided by -8 is x squared. 8 divided by -8 is -1. Oh, and notice if you make it equal to 0, we're solving. And I didn't have the 0 in at the beginning, so I put a 0 in here, which wasn't here, but if you put 0, you're going to solve it. So you take the x squared minus 1 out, and you have x cubed minus 8x equals 0, and each of those are equal to 0, and you solve them. If you keep going, so x squared minus 1 equals 0, x squared equals 1, so the square root of x squared is plus minus the root of 1, x is equal to plus minus 1. Here, x cubed minus 8 equals 0, x cubed equals 8, and this is the cube root of x cubed equals the cube root of 8. X is equal to 2. Notice there's no plus minus, because in odd roots, if it's positive, it remains positive. If it's negative, it remains negative. There's no plus minus like in square roots. So that's just showing you that if you have 4 terms, you try grouping. It makes it easier to do. And another idea that I do is that I check if 1 is a root. And how do I know if 1 is a root? Well, very simply, if the sum of the numerical coefficients is 0, 1 is a root. So if you take the coefficients and add them up, 1 is a root. So 2 subtract 2 gives you 0. So that means 1 is a root automatically. So if you put 1 in here, you'll get 2 minus 2 equals 0. So 1 is a root. Or if you go 2x equals 2 and divide by 2, x equals 1. But a very quick way, instead of solving like this, is add up the numerical coefficients. So add up the numerical coefficients right here. So 2 plus 3 minus 5, add them up, gives you 0. So 1 is a root. So if you put 1 back in here, putting 1 back in, 1 squared, watch, if you put a 1 back in and put 1 in for x, notice when you put 1 in, you get 1 squared is 1, that gives you 2. 1 times 3 is 3, minus 5. So what happens? You get 0, 0. So when you put a 1 in, it doesn't change the coefficient. When you put a 1 in, notice the coefficient is still 2, still plus 3, still minus 5. So 2 plus 3 minus 5 is at 0, so 1 is a root. Check. 1 minus 4 minus 3 plus 6. Add them up. -7 plus 7, 0. So 1 is a root. Oop, I said x is a root. 1 is a root. Why is 1 a root? Because I quickly look at adding up the coefficients. If you add up the coefficients, numerical coefficient numbers, and get 0, 1 is a root. Even this, notice a cubic. You got 1 as a root, so now you can use synthetic division and get a depressed equation and work them down. So what about this one? So I quickly check. 3, 2, that's 3 plus 2 is 5, plus 1 is 6. -4, -2, -6. So they add up to 0, so 1 is a root. So if I were doing this one, I say 1 is a root. So then I go 1, and I do the synthetic division. I go 3, 2, 1, -4, -2. Draw a line, bring down to 3. So 1 times 3 is 3, add 5. 1 times 5 is 5, add 6. 1 times 6 is 6, add 2. 1 times 2 is 2. Guess what? The remainder is right there, and that remainder is 0. So that means 1 is a root. But I knew 1 was a root because of that. The numerical coefficients add up to 0. So I check that right away when I'm doing solving cubics, quartics, quintics, etc., etc. And then when I know it, I do the synthetic division, and I get this depressed equation. Now notice that these coefficients add them up. None of them are negative. You won't get a 0 here, so that means 1 is not another root because these do not add up to 0. If these coefficients right here added up to 0 in this depressed equation, then I would do synthetic division on the 3, 5, 6, 2, and I get 0 again as a remainder. Very important. That's a trick that I use. And another thing I do is use the Dekurdi rule for possible number of positive, negative, real roots, and imaginary roots. Well, let me see. Dekurdi rule. So let's look at Notice that there's no sign changes. So in terms of reals, there's no positive real roots. So we got 3 roots here. That's a 3. So the highest degree is 3. So there's 3 roots total. So if I got no reals, I must have, I got no positive reals, I must have negative reals or imaginaries. Now since there's 3 roots, imaginary roots come in pairs. So I must have, in this one, I can't have 4 roots. So I must have 2 imaginaries, or I could have 3 negatives. Let's check out the negatives. So when I put in a negative x into here, like this, so I put the negative in, there it is. So I'm doing the p of negative x. So negative x cubed is negative x squared. Negative x cubed is the negative x cubed, the negative of x cubed. Negative x squared is x squared, so 2 times that is positive 2x squared. And the positive of a negative is a negative x plus 2 equals 0. Now I check. So if I check, notice negative to positive is 1 change, positive to a negative is a 2nd change, and a negative to a positive is a 3rd change. So I have 3 negatives, or I could have 1 negative, because when you have odd roots or even roots, you go down in multiples of 2. So you got 3 possible roots, 1, 2, 3. So I could have 3 or 1. Now, if I got 3 roots, I can't have any imaginaries. So that means I got 3 negative real roots. But if I got 1 negative real root, then I can have 2 imaginaries, and they'll add up to 3. So I use Dekurdi's rule to check, because if you notice, these are all positive. So therefore, it takes the negative number to make this add up to 0. So that means I'm looking at this and I know there's no positive real roots. So that means if I were to do the synthetic division on this cubic, I would start with the negative roots, and I'm going to find probably 1 of them, or I'm going to find 3 of them. But I'm guaranteed to find 1 of them because the power is odd. So that's just a review of the tricks that I'm going to use to solve the polynomial equations. Very important. And I'll show you every time I do one, I will go through that list, and that way it makes it easier to find the roots. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.